Well, first of all, I want to thank everybody for being with us today for this webinar. We've had a lot of very good feedback on it. Nice thing I can say is that we're actually in the process of updating it and bringing it into the era of 2015 and forward. So we should have that up and going soon. It'd be nice to see some of the new updated products like the RapidRH 4.0 EX, things like that. Informationally, it's not going to be a lot different, but it's definitely going to have a lot different feel to it. For those of you who don't know, my name is Jason Spangler. I'm the division manager for flooring for Wagner Meters. I'm responsible for not only the RapidRH product line, but for our line of hand meters in relationship to wood flooring and finished wood flooring products. As we go through this Q&A, definitely go through and type in your questions. If for some reason I'm not able to get to them, I will respond to them via email. I'm usually able to get through to all of them, or get through all of them, but if not, I will respond. The second thing is that if for some reason you don't think of the question until after we are off the air, please don't hesitate to give me a call directly. My phone number is 800-634-9961, extension 235. I'm definitely here to answer any questions that you have about the product specifically or about concrete moisture, things of that nature. That's what I do all day. So without further ado, we'll move forward with the questions that I have. Looks like the first one comes from Kevin, and he's curious as to whether or not this presentation will be available to review at a later date. So there's two things. First thing is you can find this webinar but broken out in pieces, so there's like 20 different pieces, is available. It just depends on, it's not done in one continuous flow, and there is a reason behind it, but I won't bore you with the details. The second option is that there is a website called AIAspec.com. And on there is an AIA accredited or an architecturally or a specifier driven presentation that has a lot of the same information. It just doesn't have any product specific mentions in it. That is actually available. All you have to do is give an email address. You can sign up for that, and that can be done on demand. So you do have that option. Again, it's AIAspec.com. Looks like another question came in from Joe. Joe wanted to know what the cost of the kit is. If you're looking at a RapidRH 4.0 starter kit, it's going to have 5 sensors, a reader, vacuum attachment, wire brush, insertion tool, drill bit. So all intents and purposes, it's going to have everything except for an SDS hammer drill and a shop vac. Well, besides the guy that needs to drill the holes. But those two pieces of equipment, you're looking at about just under $500. After that, then all you're looking at really is to replenish the sensors in the kit. The sensors themselves can range anywhere from $38 a piece down to $27 a piece, depending on how you do or how you purchase them. The other thing I always tell people too is keep in mind, we came out in January 1st of this year, we came out with a RapidRH 5.0 product, which is a reusable sensor. For the right type of people, that is a good option. It's a very limited population of people that are out there, but for the right type of people and the right type of industry, that is definitely a good option. Nice thing about it is we're the only company that's out there right now that has the ability to be able to talk to you from a business perspective about when a single usage versus a reusable is appropriate, because we're the only company out there that can actually have both of them, because we do have that patent on the single usage concept with the RapidRH 4.0. Next question. One of the things that comes up on a consistent basis comes down to, I understand we need to drill to 40%, of the slab thickness. The problem I have is I don't have any way of knowing how to figure out how thick the slab is. So I wish there was a really easy that you could go out there with like a witching stick or something like that, and it would tell you exactly how thick the slab was. But unfortunately, there's not an easy way of doing it. Not saying that it's really hard, but there's no real easy way to do it. What I will say is that when you have it in your head that you're looking for that kind of information, I think you'll be amazed at how easy it is to come up with it. It's kind of one of those things that if it's not something you really have to look at or think about on a consistent basis day in and day out, then it seems like it would be more difficult than it really is to come up with the information. So there's two ways. If you're looking at rehab or renovation work, a lot of times when they do certain things like moving plumbing, changing bathrooms, things of that nature, to where they'll have trenching that they've done. If you can get in there prior to them backfilling the trenching or refilling it back in with concrete, obviously you can get an idea of what the thickness of the slab is at that point. Sometimes, depending on the type of construction, prior to them backfilling against the exterior of the building, you can see or get some information there. And again, that's when you're talking new construction. On existing, one way that I have that people will do it for just to get somewhat of a consistency basis comparison is that they'll go in with a smaller diameter drill bit. They'll pick a couple spots on the floor, definitely not making or I'm not a proponent of turning the slab into Swiss cheese and drilling holes all over the place, but a couple of strategically placed holes with a small diameter drill bit. They'll go in, they'll place the holes, they'll drill them, they'll come up with some pliable wire that they can make a J-hook out of it that's a little bit bigger diameter than the hole itself. They'll push it down, it'll squeeze that J in a little bit. As it gets to the bottom of the hole and they continue pushing, it'll spring out. You can pull it up until you feel a little bit of resistance, use a Sharpie to mark it off, and then look at the difference as you pull it out. Look at the difference between where the angle of the J was at and where the Sharpie is, and you get an idea of the thickness of the slab. Again, do it in a couple places just to get some comparison information. Now, they do make a product out there that is based off of echo impact principles that you can put on the top of the slab, and it will give you a very close approximation of the thickness of the slab. The problem with it is, at least the last ones that I saw, you were north of $4,000, and for most people that are doing this, that's not really a practical alternative. Another thing that I get a question about a lot is when you're dealing with elevated slabs in pan decking, how do we know where to drill? At what thickness do we drill? Is it 20% or 40% of the thickness? So first thing is, concrete poured in a pan is classified is drying from one side. Even if it is classified invented pan decking, it's still only drying from one side. I typically will tell people that the only way it's drying from two sides is if you can go down below the slab and look up and see concrete, and if you obviously can stand on top of it and see concrete. There has to be airflow and consistent airflow across both surfaces for it to be drying from both sides. As far as where to or at what thickness to base your measurement on, or to base your calculation off of, there's two ways that are being done out in the field that I hear about as far as how to do that. The first way is to base all of your calculations off the thickest area of the slab, so the deepest part of that pan, and drill in that deepest part of that pan. So the next question I get is, how do I figure that out? Well, first of all, the deepest part of the pan, you can usually get that off of plans. But then you need to identify where that deepest section's at. And I'll tell people that there's, for under $100, you can get a very inexpensive metal detector at a Lowe's or Home Depot. It acts a lot like a stud finder in the wall to identify wood studs, but use it on the surface of the concrete, scan across. The scanning is strong enough that it will pick up the closest areas of metal or the highest points, but it's not so strong that it'll pick up metal all the way across. So you can put it on the surface, scan across, pick up a high spot, mark it, scan across a little bit more, pick up a high spot, and then drill in the middle because that's where the deepest section is. So calculate 40% off that deepest thickness. The other way that the ASTM committee is looking at, and they're trying to, I think they're trying to do more stuff with it, is they're trying to come up with a better form of getting an effective thickness. So you take into account the shallow and the deep, get an aggregate somehow, and then drill to 40% of that and drill anywhere on the floor. So, you know, at the end of the day, ASTM is silent on where or how to drill into pan decking, but the science behind it is going to be something where you still want to maintain the 40%. And our recommendation is to identify those deepest parts and to drill 40% of those. Okay, well, it looks like that's all we have. Again, my name is Jason Spangler. If you do have any issues in the future, or if you remember some questions that you weren't able to ask right now, definitely feel free to give me a call, 800-634-9961, and my direct extension is 235. Thanks, and have a great day.